Welcome ActiveTCM aboard. Your learning journey starts now. Ever felt like hospital systems are speaking different languages? Imagine a bridge that actually works. That's the promise of DWPMH1 for Pudong ActiveTCM. It's not live in hospitals yet, but it's ready to connect the dots. So what does this magic box look like inside? Think of it as a super smart mesh network. You've got the clinical workbench, port 8788, where doctors and nurses actually do their thing, capturing patient info, creating care plans. Then there's the interaction console, port 8790, the control tower for the tech wizards, watching all the data flow, checking connections, spotting problems. Remember, this is all running on synthetic data right now, no real patient secrets here, just a demo. The whole point is to make sure everything talks to each other smoothly, from the moment data is captured until it's used. It's about breaking down those silos. Okay, how do you actually get this thing running? Well, there are options, like choosing your gaming platform. First up, local demo, quick, dirty, runs on your machine, perfect for testing if it works, but definitely no real patient data allowed here. Next, single host pilot, more serious, uses a dedicated Linux server secure with Nginx TLS proper logging, keeps config files and databases in specific locations. Docker Compose is for the container crowd, generates secrets, replace templates, run Docker Compose up build D. And for the big leagues, Kubernetes. They provide config maps, deployments, services, persistent volumes, secrets examples. But remember the golden rule across all modes, keep it locked down. Don't just blast open ports to the internet without serious security approval. Safety first. Now let's talk settings. This isn't plug and play, it needs some fine-tuning. Environment setup. Make sure your database and exchange paths are absolute, not relative. And absolutely no demo tokens in production. Identity is key. Users log in via the hospital's main identity system, and this system only trusts requests coming from specific trusted proxies. Connectors, those bridges between systems, need careful config, ID, type, endpoint, auth, timeouts, retry policies, mapping versions, allowed resources, write policies, owner. Use the templates provided, don't edit them directly. Mappings, translating data between systems, must be versioned meticulously. Track source fields, target fields, requiredness, types, code sets, units, null handling, date time zones, repeated fields, exceptions, and crucially, residuals, data that can't be perfectly translated. Finally, before going live, run checks. Liveness, readiness, health, audit chain validation. Double check everything. Alright, keeping the beast running smoothly. Daily routine, check health indicators, connector status, any dead letters piling up, unresolved MPI candidates, staged clinical data, disk space, time sync, certificate expiry, audit chain integrity. Weekly, capacity, slow interfaces, unknown codes, failure trends, permission changes. Monthly, recovery drills. Security is paramount. Use TLS, manage secrets properly, never store real keys in Git or images, rotate credentials, limit permissions. Logging default to minimal, only request IDs, protocol, status, etc. Debug logs with PCI need explicit approval and are tightly controlled. Backup. SQLite WAL is fine for pilots, but production needs robust off-site backups, encryption, access control, retention policies, monitoring, and regular recovery tests. When things go wrong, common errors include 401/43 unauthorized, 409 conflicts, 503 unavailability, MPI issues, dead letters. Troubleshooting means digging into logs, checking configurations, network, certificates, permissions, and fixing the root cause. The goal is simple. Keep it running reliably, keep it secure, and keep everyone happy.